So I is equal to omega this one. Then can I conserve energy? Only when circuit is like this, you should not do this one because some energy will be dissipated. So therefore now by applying initial energy in the circuit, Q naught square by 2C should be equal to energy at any instant, Q square by 2C plus L I square by 2. This is the oscillation energy. What is Q naught square by 2C? This is the oscillation energy. We'll call this as, this is the oscillation energy. Now, what do you mean by oscillation energy? The energy what we feed to the circuit, or the energy what we give to the circuit. With that, what it will continue. Like in SHM, what is oscillation energy? Spring block system. You are going to displace the block, no? And so the spring will get elongated by x naught. Then how much of energy is there in the system now? K x naught square by 2. That is oscillation energy, and that will be converted as elastic or kinetic energy of the spring block system. Similarly, this is what oscillation energy supplied, and we know how to charge a capacitor. So quite very simple, that one. Then what is Q? Charge at any time. I is the current. So if you know charge, you can bring also the current, or you can take help of this mathematical equations. Okay, let's plot the graphs, because the graphs are very important, because they will give still more better picture to understand this circuit. I'll go for graphs here, because all the quantities, they vary harmonically. Let's do one thing. I want expression for energy, expression for UC. What is Q? Q, we assumed it, Q naught cos omega t, no? So let me generate. So this will become Q naught square cos square omega t. So this will become Q naught square 2c cos square omega t. What we can write it as 1 plus cos 2 omega t by 2. This is the expression for energy in the capacitor as a function of time. Similarly, let's go for energy across the inductor as a function of time. UL is equal to L what is the loop equation? Minus Q by C plus L di by dt. Solving that, finish over. Q by C minus L di by dt. That only I wrote it. Or the drop across capacitor equal drop across inductor. Either way. Q by C minus L di by dt. Straight away. Huh? No, this is, you take it. So what is value of I? I is equal to Q naught like what we did in SHM, no? The similar way we should analyze things here. L omega square. So L omega square, what you can write it equal to 1 by C. From here, L omega square should be 1 by C, or let it be this much only. So Q naught omega square L by 2 sine square omega t, 1 minus cos 2 omega t by 2. So the final equation will be now we have expression for charge, current, energy in capacitor, energy in inductor. Look at all the quantities, how they are varying harmonically. They vary harmonically. So let's plot the graph. So now what is this? This UC represents spring force, spring energy. This UL represents kinetic energy of the block. Correlation, please do correlate, because in exams mathematics will trouble you a lot. So better have that logical comparison. You'll be on safer side. You'll be on safer side. This is similar to like elastic potential energy in the spring. Energy in capacitor is similar to elastic potential in the spring. energy in the inductor is similar to kinetic energy of the block. So we can correlate with the spring block system. Again, don't say so therefore block is equal to inductor. No, not like that. Just logical comparison here. Plotting graph.
Sir, in the previous step, Q naught squared omega squared, sir.
Omega is missing here. Okay, no? Omega Q naught omega square. Okay, fine, yeah. I'll write it. Let me plot the graph. First charge, no? Charge, it was a cosine function. 1/4 of time period. It's a sine function. Same value. No, this is Q naught. This is charge minus Q naught. This is T by 4, T by 2, 3T by 4, T, 5T by 4, 3T by 2, 7T by 4. If you want one more, 8T will come, or 8T by 4 will become 2T. This is for 1.5 cycle is what we have shown. Now, next one, what about the current? Look at the expression for current. So we'll write all the equation first. So this is Q equal to Q naught cos omega t. Current is equal to how much? Q naught omega sine omega t. The maximum current is Q naught omega. Okay, this is about the expression for current. Some okay, let's come for this. When current is maximum, what is the charge? This is very important. We have some around the very best numericals. 5 numericals are there just based on this information. When current is maximum, look at this, current is maximum here, no? What is the charge? 0. If charge in capacitor 0, then definitely what will happen to potential difference across capacitor 0, then potential difference across the inductor will also be 0. So when the current through the coil will be maximum, when the potential difference across it is 0, this is the definition. You have around 5 best numericals you can manage. I'll take you back to what all I'm discussing now. Please do notice this is the only thing which is going to help us. Otherwise, we'll be in a big trouble. I'm telling this one. Otherwise, we have to fight with mathematics. Sir, most of the circuits, as you can say, rather than say most, for every circuit, you can take help of this one. So when the current through the coil will be maximum, don't say charge in capacitor 0, better put when the drop across inductor is 0, when the potential difference across the inductor is 0, the current through the coil will be maximum. This is what I needed for the numericals, this information. Current current to the coil is maximum when potential difference across it is 0. So I'll just put I will be maximum when VL is 0. And you say don't generalize VC 0, because I may have some problem where the potential difference across capacitor will be non-zero also. But this is the thing which is a generalized one, which I'm going to take help of it. So how do I can say? I think I have enough thing. No, come back here. So according to graph, okay, what we have, see, like a charge is 0. If charge is 0, then VC should be 0. All of you put effort, analyze here. Don't just see the diagram, just analyze here. You say when charge 0, then VC 0. As they are parallel here, VL be 0. Rather than saying that current will be maximum when potential difference across capacitor 0, that is not a generalized one. What is a generalized one? Current through the coil will be maximum when potential difference across coil is 0. How many times it will occur? Twice, no? You can see here. These are the twice. In one cycle, twice the charge in capacitor will be 0, twice the current across the coil will be maximum. What about the, now look at the potential difference across the inductor. It will be maximum here, no? Because di by dt is maximum here. So do make observation. All this slopes, all that, they'll speak a lot here. This is the one general thing you do remember. Very important here. Let's plot the energy equation. I think now we know expression for energy. Already we have that equation, no? Sine cos. I'll paste it here. This is the energy across the inductor. So we'll plot this graph. Negative obstacle should not come, no? Sine square omega t, cos square omega t will not, negative obstacles will not be there. So extending this. How to this one? So let's plot first the energy across the capacitor. Cos 2 omega t, put t equals 0. So it will start from here. Harmonic function. So this is the energy across the capacitor, then energy across the inductor. Which is a The green color is UL, the blue color is UC. Okay, I think now you have all the information. Any theoretical questions, if they ask you, I think you can take help of this much of the graphical one. This is 3t by 2, 7t by 4. What is one cycle? This is one cycle, no? 0 to t is one cycle. How many oscillations the energy in the capacitor inductor will complete? Twice, or mathematically you can say, no? Look at what is a charge and current. By the time charge current completes one oscillation, in that interval of time, what happens? The energy in the capacitor inductor what will complete two oscillations. So shall we put like the frequency of variation of the energy in inductor or capacitor is twice the frequency of the charge variation in LC circuit. Similar in SHM, this one. So the statement is there. The frequency of energy variation in capacitor and inductor is twice the frequency of charge variation. If f is the frequency with which charge is varying in LC circuit, what about the magnetic and electrostatic field energy? It will be twice. That's what the graph is telling. So now you see at one instant both are equal, no? At one instant of time both are equal. How many times in one cycle they'll be equal? So this is what still with respect to charge only we say one cycle. What is one cycle for us? Time taken for the charge variation to complete. This is a one cycle. How many times the energy across capacitor and inductor will be equal? Here is one. You can see both 2, 3, 4. So what can be this interval of time? This interval of time. So it will occur at some sequence order, no? This one. So how many times in one cycle the energy will become 4 times. So let's try to calculate here. So what is the equation of mathematics? UL is equal to any graph. Please do remember graphs. So any graphical questions can also be asked. So let's go for UL equal to UC. This should be equal to Li square by 2 Q square by 2C. So L. So what is I is equal to? I should be equal to Q naught omega sine omega t whole square Q naught cos omega t whole square. L omega square sine square omega t cos square omega t. Here one C is missing. So omega square equal to 1 by LC. So that will get cancelled, or you write it LC omega tan square omega t equal to 1. We know omega square equal to 1 by LC. So therefore tan square omega t equal to 1. What are the values? What are the instants of time at which it will be? Pi by 4. This should be, so omega t should be equal to omega is 2 pi by t. Now take help of trigonometry. Is it only t by 8? Is it only t by 8? From t equals 0 at t equal to t by 8 it will occur. Then again 3t by 8, 5t by 8, 7t by 8. What are the times at which this will be t by 8, 3t by 8, 5t by 8 in one cycle. For this, at this instant of time, UL will become equal to UC. So the time at which the energy across the inductor will become equal to capacitor, this is a condition. Any other ways they can ask you the time at which energy across capacitor is twice of that of inductor. So maybe that situation is asking somewhere here. So any graphical questions can be asked, you have to be very careful. And what is the average energy stored in the inductor? Average energy stored in the like a capacitor. What to do for that? I think you have to take help of mathematics here. No? In one cycle, what is the average energy stored by the inductor? Should be zero, non-zero. No negative of cycle, should be non-zero. How to calculate that average energy? Average energy stored in capacitor should be equal to, this is U of capacitor dt by average energy stored in the inductor in one cycle, UL dt by 0 to t. Work out all this trigonometry, math based one. Keep this ready. You should have this information in hand in exams. You can manage because they give information like what is the average energy. They'll give this as information. Based on this, a problem will be linked for you. What is the average charge flown? Again, go back to the same idea. Average charge should be zero, no? Because negative off cycle is there. Average current should be zero. Positive and negative off cycles are there. Average energy should be, because negative off cycle not there, so there'll be average energy will become. The sum of UL by UC at any time, at any instant of UL by UC should be equal to again Q naught square by 2C, equal to oscillation energy. The sum of UL plus UC at any time should be equal to oscillation energy. That oscillation energy, how we supply, either through capacitor or inductor or through both, it's left to us. Okay, these are all some technical things which a student must have a background initially. Okay, let's go for now some application part. I'll have water. Huh? Let's take the now some different types of circuits.